Question 8 asks me to convert each equation to slope-intercept form. These equations are at least in the case of A and B, standard form right now. In the case of equation C, it is in a mixed form. Being able to convert an equation into slope-intercept form is an essential skill. It's what we call solving for y. When I have a y equals equation, and it's a linear equation, as soon as I've solved it for y, it's in slope-intercept form. And I need it to be in slope-intercept form and able to graph it and able to tell what the slope and the y-intercept of a given line happen to be. If you can do this, you can pass this test. If you cannot, you probably will not. So we must master this skill. If you were going to master only one skill, this is the one to do. So I start with 8x plus 3y is equal to 15. In order to get this into a y equals form, to solve for y, I first have to move the x term. If the x term's positive, I do that by subtracting 8x from both sides. So when I do that, that cancels. I bring down 3y. 3y is equal to 15 minus 8x. That's step one. Step two, I need to divide by the coefficient of y. The coefficient is the number in front of the variable. In this case, it's a 3. I must divide each and every term by a 3. When I do that, 3 divided by 3 cancels out. I get y is equal to 15 divided by 3 is 5. If I put a negative 8 over 3 into Desmos, Desmos will check to see if it reduces. In this case, it does not. So I get y is equal to 5 minus 8 over 3x. That is in slope-intercept form. It doesn't matter which order I have the slope and the y-intercept. I could have this as 5 minus 8 over 3x, or I could have this as negative 8 over 3x plus 5. You could type that in either way. The edge elastic will accept it either way, and I will accept it either way. That's just a matter of personal preference. Y is equal to b plus mx is the same as y is equal to mx plus b. I can add in either direction, one of the properties of addition. I enter it into my edge elastic, and I'm ready to go. Moving on to b. b is negative 4x minus 4y is equal to 16. Now, at this stage, it's important to say something about not forgetting your negatives. It's very common for students to get in a bit of a hurry here and accidentally lose track of a negative. Now, if you lose track of a negative, you will have this equation wrong, and you can miss a lot of credit on this test by losing track of your negatives. So we want to be very careful with this. I have negative 4x minus 4y is equal to 16. I must move that x term first. Now that the x term is negative, I do that by adding the x term to both sides of this equation. So I will add 4x to both sides. It's very important that I make sure to keep track of the fact that that is a negative 4x. And so I have to add 4x. If I put minus 4x on the other side, that's going to be wrong. So I proceed forward. As I do, I will write plus 4x on both sides. It's important that I do one step at a time. Don't do multiple steps at once. One step at a time. I must bring down negative 4y. If I lose that negative when I bring it down, if I only bring down 4y, I will get this problem wrong. Do not forget your negative. If it seems like I'm harping on this a little bit, it is simply because students do this a lot. And then when I divide each term, I have to divide it by a negative 4, not just a 4. As I do, a negative 4 divided by a negative 4 cancels out. I get y is equal to 16 divided by negative 4 is negative 4. Positive 4 divided by negative 4 is a negative 1. In this case, I don't need to write that. I can just write negative x, and that 1 is implied. And so then I would switch over to my etch elastic, and this is what I would put in. Y is equal to negative 4 minus x. Edge elastic will probably recognize this if you put a 1 in front of the x, but you don't have to. You can just type negative x here. And again, you could write this as y is equal to negative x minus 4 if you wanted to. If you want to switch them, that's fine. Since this is how they ended up when we simplified them, that's the way I'm going to leave them for now. They'll be in a different order on problem C. So moving back, let's do C. C is a little different because instead of having standard form where I have the x and the y term on one side of the equation, here I have a constant over with the y term. The constant is the number by itself, 15. That's going to end up being a part of my y-intercept. 15 minus 3y is equal to negative 30x. My process is very similar. I need to move that 15. I need to move it by subtracting it. I will subtract 15 from both sides. That cancels. I bring down negative 3y, and it's equal to negative 30x minus 15. Please do not lose track of any of the negatives here. When I divide, I must divide by a negative 3, and I have to do that to all three terms. I have seen a lot of students in the past few days that will only divide the x term by the negative 3, but they leave the other term, the constant, alone, and they don't divide it. You must divide all three terms. When I do, negative 30 divided by negative 3 is 10, positive 10. Negative divided by a negative is a positive. Negative 15 divided by a negative 3 is a positive 5. I'm going to switch over to Edge Elastic at this point. There's a little shot of my home screen. Struggling with my iPad a little bit. I'm going to go in and I'm going to type this equation in. In this case, I'm doing it blind. Hopefully this ends up being good. You won't have to type it blind. On the computer, you'll have more space than I have here. I get y is equal to 10x plus 5. Let's move on to problem number 9. Problem 9 is similar to problem 7. I'm given a table of values, and I'm asked to use this table of values to determine the slope. I just need to remember that a table of values is just a list of ordered pairs, x values and y values. Sometimes my table might say x and f of x, or g of x, or t of x. If I get that in function form, I just need to remember that g of x, t of x, f of x, those are all equal to y. And so these are just ordered pairs, negative 2, comma 2, negative 10, comma 7. I'm going to use those top two, and I'm going to label them x1, y1, x2, and y2. I will recall or look up on the board come test A and remember that my slope formula is m is equal to y2 minus y1 over x2 minus x1. That's the difference in my y's over the difference in my x's. And now I'm going to plug these values in. I'm not going to do this in my head. Cannot emphasize that enough. I'm going to write it down. If I don't write it down, I might make a little mistake and lose points that I should have on this test. Notice something interesting happens when I put these in. I get the dreaded double negative. Remember, when I have two negatives that are right next to each other like that and there are no numbers in between them, they turn positive. And so in this case, I'll get 7 minus 2 is 5, and negative 10 plus a positive 2 is a negative 8. If I put that in Desmos, I can check to see if it'll reduce. In this case, it does not. I get negative 5 over 8. I'm going to switch over. I'm going to pop that into my edge elastic. I'm going to use the forward